1.4 Finding limits from tables. Calculator is required. If we have this graph here on the right, at this point it is easy to see the value of limit as x approaches 3 of f of x. As x approaches 3, right here, this is x equal to 3, right? On the graph, you see from the left and the right, we are approaching a value of y is equal to 4. So without a graph, we could also use this table of values. If you look at the x, this is like as if we didn't have the graph, right? You can see the x values is getting closer and closer and closer to 3 from the left, so like values a little less than 3. And then from the right, we're approaching 3. You see the values are a little greater than 3, but on both sides, you can see we're approaching an f of x value of 4, which would be right in between here on both sides. Because 4 is right between like 3.99 and 4.01. So number 1 right here, what's the value of limit as x approaches negative 4 of f of x? You see as x approaches negative 4 from the left and right here, you see the f of x is going from 2.43 to 2.499, just stopping shy right of 2.5. And then from the right, 2.68 to 2.501, stopping shy just of 2.5. So right here, the limit as x approaches negative 4 of f of x is 2.5. Remember, this is asking us the limit as x approaches negative 4. They're not asking us for f of negative 4 because we would not know what that is because they don't tell us. But we can see from the table as the x values are getting closer and closer to negative 4, f of x is approaching 2.5. So, question 2, this is where you need to get your calculator out. So, f of x is equal to that whole thing. Create your own table of values to help you evaluate limit as x approaches negative 2 of f of x. So we have to kind of create our own values. We could just put as x approaches negative 2. We could do negative 2 here in the middle. Pick a value that's a little less. Sorry, that's actually wrong. I got that confused. That's a very good mistake I made. If you remember, values a little less than negative 2 would be like negative 2.001. And a value that'd be even less would be like negative 2.01. Be very careful with that. I just made a mistake. That's fine. Catch yourself when you do. And values a little greater than negative 2 would be like negative 1.999. And then a value a little greater than that would be, I don't know, we can do negative 1.99. Just move one of the 9s there. You can pick whichever numbers as long as they're really close and tiny there. So on your calculator now, so you're at the home screen, the first thing you want to do is change your table settings. So if you go to second window, that's table set, change the independent to ask. This will allow you to input your own x values instead of it generating it for you. From there, we want to type in the actual function. You see this is a fraction here. You can do a trick here, you can do math, num, right arrow key, up, the n divided by d. That gives you a nice fraction format so you don't have to worry about parentheses and order of operations. Type in the whole function here. If you have questions with how to input this in the calculator, you can rewind the video or ask your teacher for assistance. So once you have the function inputted here, you can go to the table, so second graph, because the table is blue here. And now all you want to do is just input your x values you made here. Negative 2.01, enter. Negative 2.001, oops, delete, enter. Negative 2, enter. You see it says error here, but that's because it's actually undefined, because you can't have a 0 in the denominator. Negative 1.999, negative 1.99. If you want to just put these values in, you see it automatically generates the output here. So see it's 21.1, 21.01. Make sure you get the same values on your calculator. This is DNE because it's error. 20.99 and then 20.9. All right, so you can see here as x values are approaching -2 here, even though at -2 it's DNE, right? Like if they asked us f of -2, that wouldn't exist. But as we get closer and closer and closer to -2, but not at -2, you see we're approaching values really, really close to 21. So that's our limit there. That was the table values method here of finding these inputs here. If you just want to use function notation, if you go to the home screen, so let's see, go to second mode, that gets you the home screen. If you click on VARS, right arrow key, function, Y1, and do parentheses like -2.01. This just does like f of -2.01. You're going to get the same answer, but it's a little more accurate because it gives you more decimal places. The table can, the table's quick, but it doesn't give you more decimal places. For the table values is fine, but later on you'll need to know how to use the function notation here. All right, so we covered those two. This last question here. The function f is continuous and increasing for x is greater than or equal to 1. The table gives values of f at selected values of x. Approximate the value of limit as x approaches 2 of cosine of f of x. So you see here the table as x values approach 2. You see f of x is approaching 5. So don't let this cosine distract you. Just pretty much, you can think about this as like the limit as x approaches 2. You see it's approaching 5. That's clear here. So just replace the f of x here with a 5. And you can just leave your answer like that. Another way you can think about this is if you just kind of rewrote this problem as cosine of and just put the limit on the inside. You see here, we're just putting limit on the inside. This right here is equal to 5. So we just replaced it right here. The limit as x approaches 2 of f of x is just equal to 5. So just do it like that.